All right, so I'm going to look at one or two of these tricky cases that appear on your paper in this video. So the first one that I want to look at is problem, sorry, that was my web link for your integrals if you don't have them on in front of you. Okay, so try again. I'm going to look at problem number 40, and that one is the integral from -1 to 1 of the absolute value of x dx. So this is one where you have to remember what integration is all about. And integration is all about finding what is the area under the curve that goes from the line to the x-axis. And my equation, y equals the absolute value of x, looks like a v when you graph it on an xy coordinate plane. So what you're trying to find is if we go from -1 to 1, what's the area here? And what's the area here? Now you could technically change this into a piecewise function because the integral here would be the integral from -1 to 0 of a negative x dx. And then you would integrate from 0 to 1 of a positive x dx. And feel free to go through and do this and use your basic rules. As I'm doing here. I personally would not. There might be other shapes, other equation shapes that I would use these rules on. But I personally feel like this would be just a little bit too much work when I already know so much about triangles. Not to say I'm not going to finish this problem for you. Alright, so this one would be 0 squared minus -1 squared plus a positive 1/2 with a 1 squared minus a 0 squared, which gives us -1/2. -1 squared is 1, but then we're going to take the negative of it here, so times -1 plus a positive 1/2 times 1. We end up with 1/2 plus 1/2, which gives us 1. Now you can feel free to do this. There are other shapes that maybe I'm not as well acquainted with as I am with the triangle that I would want to do this method on and break it up into a piecewise. For me personally though, I just look and say, well, you know what? I know that I'm looking for an area. I know that this is 1 unit long. I know that when I plug in -1 or 1, I can find that the height of both of these triangles is equal to 1. And I know that the area of a triangle is equal to 1/2 base times height. And I've got two triangles, so I'm going to take 2 times the 1/2 base times height, because they have the same base and same height. And again, I just get that my area is going to be 1 unit squared. To me, that's a simpler solution, and it helps to reinforce the idea that we're looking at areas, and I can find areas in more methods than just integrals in some cases. Obviously, we're teaching you integrals because we're trying to look at those cases where you are not familiar with how to find the area. But use these sort of tricks as you go through. Another one that I see that I think you guys actually have been good about this one. Number 43. I don't think I've seen anybody get tripped up by this one. But this is the integral from 0 to 1 of pi dx. I'm grateful to the people that made these basic skills integral sheets because a lot of times we see a symbol and we think that it must be a variable, and obviously pi is a constant. So when you take the integral of this one, it's going to be just as simple as putting an x with it and then going through the bounds. So this will give you pi times 1 minus pi times 0. I guess I don't need the parentheses there, but can't have too many parentheses, which gives me just pi. We'll pause there and I'll see if there are any other problems. I think I'll do both of the second fundamental theorem of calculus problems next.